Okay, Jennifer, this one is for you. Lenses is the lesson that we're going to be working on next, and it is not complicated, but there's lots of terminology between this one and mirrors that we need to be able to keep straight. So we're just going to go through this. Lenses have two groups. One is called a converging lens, where they will focus a light. And notice that we have two shapes. We have this shape here where it's bulging out, or where we have just half of a lens. This is reminiscent of glasses. Most glasses are thicker in the middle than they are at the other end. And so all we've done is we've taken a converging lens and we've split it in half. This is a diverging lens. Or we look at one half of it like this. And again, we've just taken this and split it down the middle. Okay? The greatest and easiest way to explain what's happening is by drawing what we call a ray diagram. So when we were in the forces unit in Physics 20, we always did a force diagram, force normal versus force gravity, force applied versus force of friction. We're going to do ray diagrams in lenses, and it's going to tell us if the image is flipped or not flipped, if it's larger or smaller, a bunch of different qualities like that. And so what happens is that we have to have two other extra pieces. We need a principal axis, which is an imaginary line that runs perpendicular to the lens and cuts through the length of the lens itself. And then we also have the principal plane. So it's perpendicular to the principal axis and it runs lengthwise through the middle of the lens. So if I was to draw a line, maybe I should show you what's going on. If I was to draw a line and I was to put a converging lens on this line here would be what we call the principal axis, because it cuts this lens halfway through. This dotted line that goes directly down the center, this is called the principal plane. Notice that the principal ends in PLE and not PAL. This is not your PAL. This is a concept, principal plane. Principal axis, principal plane. This type of lens, this is a lens, and it's a converging lens. And we have right dead center, so halfway between top and bottom, halfway between the outside edges. We call this the optical center. And then we have out here, usually equal distance. We call these focal points. Okay, so the optical center is dead center, and focal points are drawn on both sides of the lens, and they're the point where the parallel light rays meet after passing through a lens. It's like two ships passing in the night. Okay, when an object is placed in front of a lens, the image can have different characteristics. So if we had, those of you that wear glasses will totally understand what this means. Take your glasses off, you can't see as far, maybe things are blurry, maybe images are not there. So we can see smaller or larger, or we can see same size. And we can see it inverted or upright. Okay? Those are the defining, the empirical things that happen when we work with the lens. Now the image type, this is a little bit harder to see. Virtual or real. Real images are projected onto a screen, which means that the images are on the opposite side of the lens in comparison to the object, whereas virtual images can be seen, but you can't project them because they're not there. They're on the same side. So if here's our lens, here's where our object is, and if it's a real image, we can project this image onto the screen and we'll see it. And it'll appear that it's here. But a virtual image, we won't see it because its image will be here out front. Okay? There are 1, 2, 3 rules for drawing a ray diagram for a converging lens. We're always going to start with our principal axis, and we're going to start with a converging lens. This is just the habit. I automatically draw the principal plane and the principal axis, and I draw everything just like this. Here's our focal point. Here's our second focal point. And here's our object. Okay? So rule 1 says any ray passing through the focal point of the lens will refract parallel. Passing through the focal point will refract parallel to the principal axis. And this is where your ruler becomes your best friend. So if you don't have one, now's the time to get one. Okay, you go from the tip of the object and you pass it through the focal point until, and of course, I didn't draw my lens big enough. Until it hits the lens. Once it hits the lens and it hits this middle line here, then we go parallel to the principal axis. Okay, so it's going to come this way and it's going to go through this way. So this is the object that gives off light. Otherwise, how would we see it? That's the first rule. So the first rule is you go from the top of the object through the focal point until you hit the principal axis. Until you hit the principal plane, and then you go through parallel to the axis. The second rule says that you have your object. And draw a bigger one. So make sure I don't mess up. My focal point. My principal plane. My principal axis. I'm going to do step 1, where I go from the tip of the object through the focal point until I hit the principal plane, at which point I'm going to go parallel to the principal axis. Okay, that's step 1. Step 2 kind of does the reverse. It goes parallel to the principal axis and then passes through the focal point. So we're going to go parallel from the tip of the object, parallel, it's kind of parallel, till I hit the principal plane, and then I'm going to go through this focal point. And it goes this way. I got cheap on my purple. Spin this guy all out. There we go. Okay. What we see is, Mrs. Pyre would have drawn this right all at the beginning, is that where these two lines meet is our image. Okay? So rule 2, any ray parallel to the principal axis will refract so that it passes through the focal point. For a concave lens, ooh, I hear a little bit of grade 8 coming back to haunt us. A ray will hit the lens and diverge or scatter, which means you would need to extend the diverging ray to the focal point on the opposite side to the lens. Okay, what do we know about this image? Well, let's physically look at it. It is 11 millimeters, and this one is 15 millimeters-ish. So this image is larger, and it's inverted, and it's on the opposite side. It's been projected through, so it's real. Okay, so that's this image for a converging lens. Seems easy peasy, except for we're going to do it for a diverging lens. I'm going to take this wonderful line that's already here, and I'm going to put in my diverging lens. I'm not going to cap it in case I didn't draw it big enough. Not going to cap it in case I didn't draw it big enough. I'm going to put my object here. I'm going to give my focal points here and here. Usually they're equal distance from principal plane. Okay, so rule number 2, what we're going to see here is that it's going to go, now there's no this, there's no running it through the focal point and then hitting this because it's going to scatter. So what we do, there's no purple line, there's still a yellow line. We're going to go perpendicular, not perpendicular, we're going to go parallel to the principal axis till we hit the principal plane, the center of it, and then we're going to take the focal point and we're going to show how it scatters. Okay, so it's going to go out this way. So you take it from the tip of the object, you go to the diverging lens. From the focal point, you meet up where it meets the principal plane, and then you extend it beyond the lens. No purple line, only a yellow line. Rule number 3, it says any ray that passes through the optical center of the lens will pass through without any refraction. This rule applies to both types of lenses. So let's do this. I'm going to get 2 pictures in this area. So my converging lens, my focal point, and my object. So remember, the first law is it goes from the tip of the object through the focal point, through to the principal plane of the lens. This is rule number 1. Goes here till we hit the principal plane. Then it runs parallel to the principal axis. It's nice and long. Rule number 2 is it runs parallel to the principal axis from the tip of the object to the principal plane, and then it runs through that focal point. This. So already we can predict something happening at this point here. But then rule number 3 says we go from the tip of the object through the optical center with no refraction. Where am I at here? It's a pink line. 3rd line. Ta-da! And look at that. Here's our second image, where our image is inverted. It's, what do we got? We got 8-ish. And here we got 10-ish. So it's larger. It's real because it's on the other side of the lens. Okay. Now, if we were to do a diverging lens, we can cap this guy off. We do a diverging lens, and its center, highly technical, and its focal points and object. Haven't changed anything. This is exact same. But remember, in a diverging lens, there's no rule number 1. There is a rule number 2 where we go parallel to the principal axis. We run to the line, principal plane, where we hook up with the focal point. And we extend it beyond. And then we also run it through this line here, through the center. It says, this rule applies to both types of lenses. Any ray that passes through the optical center of the lens will pass through without any refraction. We're going to go through the optical center from the tip, like that. And what do we see? Well, I see a line right here where the 2 lines cross. Oh, my goodness. You missed all my fancy drawing. Right here, 2 lines cross. So just to recap, because you missed, I went parallel. I drew it from the focal point out. I followed rule number 3, where I drew my line from the tip of my object through the optical center and out. And lo and behold, this is where my lines cross on a diverging lens. And what do we see about this? What's the physical attributes? This is about 8-ish. This is about 3-ish. It's smaller. It's in the same direction as the image. It's upright. But it's not projected beyond the lens. So it's virtual. Okay, because it's in front of the lens. The image appears in front of the lens. So it says, determine the characteristics of the image using a ray diagram. So I'm going to draw this for you. This is what you get. From me to you. Merry Christmas. Here we go. I'll figure out my camera yet. Here's my principal axis. I'm going to give you a converging lens. Principal plane like this. Two focal points like this. Equal distance from the optical center. And I'm going to give you a very tall object. Okay, here's the example. What's the first rule? First rule is from the tip through the focal point to the principal plane and then parallel out. Okay. Oh, I have a page. This is rule 1. Rule 2. We're going to go from the tip. We're going to go parallel till we hit the principal plane. Obviously, that's not perpendicular. Or parallel, I mean. We're going to go parallel to the principal plane. And we're going to come through this focal point. This is rule 2. Oh, jeepers. Quit moving my paper. And then the third rule is you go from the top of the object through the optical center. Magic. They all meet. That was rule 3. What can we say about the image? Now, what happened here? We are 20-ish millimeters. Here we're only 12-ish, no, 17-ish. It's smaller. It's inverted. Did it get projected? Absolutely. So it's a real image. Let's look at one like this. This is another example. Let's look. This is important that you understand it. I don't know where you're going to draw it. Be creative. We're still going to use a converging lens. We're going to do the principal plane. We're going to put our focal point here. We're going to put our focal point here. And then we're going to put our object right here. Well, how's that going to work? Well, it's going to work like this. Are we going to have a rule number 1 where we go through the focal point until we hit the principal plane and then go parallel? Can we go through the focal point? We can't, because the object is after the focal point. So there's no rule 1. Okay. Rule number 2 says run parallel to the principal axis like this, and then through that focal point, which we're going to do But knowing that this image, in theory, or this line, this ray, extends that way as well. Okay? So this is rule 2. Rule 2. Rule 3 says, go through the optical center with no refraction. You can do that. Okay. Now, where do the lines meet? The lines meet right here. That's where the lines meet. This is the object. This is the image. What can we say about this image? We can say that it's upright. We can say that it's larger. Can we say that it's real? Absolutely not, because it's not projected. It's actually behind the object. So it's virtual. So what happens is these lines don't converge. Hence a converging lens. These lines don't converge, therefore we have to extend the refracted lines back. Okay, so this is not a real image. It's behind us. Not that you can see me pointing to behind my back, but that's just what I did. Okay. Oh, wrong one. Bum, bum, bum. Let's do these. Page 217, questions number 1 to 3. Don't do a dimensions chart. And for number 2, when they say a positive lens, they actually mean a converging lens, something that's going to give you an image beyond, in theory. Okay? I'm going to actually, where am I at? I'm going to stop this. This is 27 minutes. Your brain needs a break. Come back, watch the second video.